You know, when you think about the most powerful forces on our planet, volcanoes have got to be right at the top of the list. They're these dramatic, incredible reminders that our world is a living, breathing thing capable of both breathtaking beauty and, well, terrifying destruction. So, in this explainer, we're going to journey into the heart of these fiery mountains to really understand that dual nature. And this quote right here, it just hits the nail on the head. It perfectly captures what we're talking about. I mean, think about it. Volcanoes are this ultimate paradox. They hold the power to create and the power to destroy, sometimes at the exact same moment. They really are both the beauty and the beast. All right, so here's the game plan for today. We're going to start with the basics. Why do volcanoes even exist? Then we'll look at what makes them erupt. After that, we'll climb a ladder of destruction to see just how powerful they can get. We'll even meet the folks who study them up close. And then we'll get to the big one. What happens when a super eruption finally blows? Okay, so to really get this, we've got to rewind the clock, like way back. Right from the very beginning of our planet's history, volcanoes have played this absolutely vital role. They're the ones that release the heat, the gas, and the minerals that were essential for life to even get started. Just let that sink in for a second. We're talking about a force that's been around for 4 billion years. They literally created the atmosphere that we're breathing right now. So the bottom line is this: as much as we fear them, if volcanoes didn't exist, well, neither would we.
So how does it all actually work? What makes these things tick? To understand their immense power, we've got to peek beneath the Earth's crust. So let's dive into the anatomy of an eruption.
So picture this. The Earth's surface isn't some solid shell. It's actually a giant jigsaw puzzle made of these massive slabs we call tectonic plates. And it's right there at the edges where all the action happens, where they grind together, pull apart, or dive under each other. That molten rock, or magma, finds a way to escape to the surface. And believe me, nowhere on Earth is this more dramatic than the Ring of Fire. This thing is a massive belt that circles the Pacific Ocean, and get this, it's home to a staggering 75% of the world's active volcanoes. It is, without a doubt, the most volcanically and seismically active zone on the entire planet. Okay, so what's the secret ingredient that decides if an eruption is a gentle ooze or a planet-shaking explosion? Well, it all comes down to the magma. Think of it like this. Thin, runny magma lets gas escape easily, so you get those slow, oozing lava flows. But thick, sticky magma, that's a whole different story. It traps all that gas, building pressure until, boom, you get an explosive, catastrophic eruption. And that huge difference in magma is the perfect lead-in to our next section. See, not all eruptions are created equal. Not by a long shot. So let's climb what I like to call the ladder of destruction and see how scientists actually measure this incredible power. All right, this is going to be our guide, the Volcanic Explosivity Index, or VEI for short. It's a scale that goes from 0 to 8, but here's the kicker. Each step up isn't just a little more powerful, it's a massive leap in explosive energy. We're going to walk right up this scale, starting at the bottom. So let's start at the bottom, right? At a VEI of about 0 to 1, you've got Hawaii's Kilauea. This is that classic, slow-moving but totally unstoppable lava you see in documentaries. Back in 1990, its flows completely swallowed the village of Kalapana. But at the same time, the volcano created over 200 hectares of brand new land. I mean, talk about creation and destruction happening right next to each other. Okay, now we're jumping up the ladder to a VE3 with the Soufriere Hills volcano in Montserrat. And here, with that thicker magma we talked about, we meet a new, much deadlier threat, the pyroclastic flow. I want you to imagine a superheated avalanche of ash, gas, and rock, and it's hurtling downhill at over 100 kilometers per hour. Just terrifying. And listening to a survivor, Roy Daly, man, it just brings the terror of these things home. He talks about a darkness so total you literally can't see your own hand in front of your face, with this superheated ash all around. It's an experience you can't imagine. All right, big jump now. Up to a VEI 5, Mount St. Helens, 1980. And this one was different. This wasn't your classic volcano blowing its top. No, this was a rare, sideways lateral blast. It blew out, not up. The force was just insane, over 1,800 times the power of the Hiroshima atomic bomb. And the whole thing happened so fast, it's just mind-boggling. Check this out, in just 16 seconds. 16 seconds. An earthquake shakes the mountain, the entire north face collapses in a landslide, and that basically uncorks the volcano, unleashing this sideways blast that just vaporized 600 square kilometers of forest.
Okay, we're getting near the top of our ladder. One more step up to a VEI 6. And this brings us to Mount Pinatubo in 1991. And for the people of the Philippines, that massive eruption, well, that was just the start of the nightmare. It was a disaster that unfolded in stages.
So what happened here was just this perfect storm of disasters. First, you get this massive eruption, sending an ash column 35 kilometers into the sky. But then, a typhoon hits at the exact same time. The rain mixes with all that ash, making this heavy, wet cement that just collapses roofs. But it gets worse. That same sludge formed these deadly mud flows called lahars that buried entire towns. And the ash cloud from this thing, it was so huge, it went global, actually cooling the entire planet for a couple of years. I mean, these events are just absolutely devastating. And that's exactly why scientists risk everything to try and understand them, to predict them. So let's take a minute to talk about the people who work right on the front lines, literally living in the shadow of these giants.
You know, the toolkit these scientists have is pretty incredible. They listen for tiny earthquakes with seismographs, they use GPS and radar to measure the ground swelling up like a balloon, and they're even sniffing the air for changes in gas emissions. They use thermal cameras to spot hotspots, and my favorite? They drop these little remote data correctors they call spiders right into the craters to get real-time info.
But, you know, this hunt for knowledge, it comes at a huge price. This is an unbelievably dangerous job. To get the data you need to save lives, you have to get dangerously close. And tragically, in the last 60 years, at least 27 scientists have made the ultimate sacrifice doing just that. Okay, so we've climbed this ladder all the way from a 1 to a 6. But what's at the very top? What happens when you get to a VEI 7 or even an 8? What does a real super eruption actually look like?
Well, to get a picture of what that might mean, let's look at a place called Campi Flegrei in Italy. Now, this isn't some classic pointy volcano. It's what's called a caldera, basically a collapsed supervolcano that's 13 kilometers wide. And the scary part, hundreds of thousands of people live inside of it, and scientists are pretty sure it's capable of an eruption that could literally change the course of human history.
So let's really put this into perspective, okay? Remember Pinatubo? That was a VEI 6, a massive climate-altering event. A super eruption is on a whole other level. We're talking almost 50 times more ash, a volcanic winter that could cause global temperatures to drop for 5 years or more, and a potential death toll not in the hundreds but in the millions. It's a leap in destructive power it's almost impossible to really wrap your head around. And that brings us right back to where we started. It's this wild idea, right? These same incredible forces gave us the world we live on, the very air we breathe. And so the final really unsettling question is, could these same forces that have been here for 4 billion years also be the thing that one day causes our end?